In this video, we will practice graphing the cotangent function and the, more secant function. Alright, but first, problem number 3, cotangent. I'm noticing that we have a b value and a potential phase shift, which is not pi over 2. So before I do anything else, I want to factor that 2 out of the parentheses. So I'm going to put the 2 outside like this. And to figure out what comes next, I need to take pi over 2 and divide by 2. Now I know that that's going to be pi over 4, because I've learned if you divide a fraction by a number, all you really have to do is put that number you're dividing by into the denominator and multiply. But that's like a trick I memorized, so you might be more comfortable doing it out. So if I have pi over 2 and I'm trying to divide by 2, then of course we multiply by the reciprocal. So that's pi over 2 times 1/2. Multiplying straight across does in fact give you pi over 4. So if that makes you more comfortable, then there you go. I want you to be comfortable. I want everyone to be comfortable in my videos. Okay? This is my house, but I want you to be comfortable. So I'm going to go ahead and put this cotangent out front and the 2, and now we can make this thing happen. We have an a value this time, which is not the amplitude, because cotangent, similar to the way tangent goes up forever and down forever, so does cotangent. So there is no amplitude, but the a value is still important. It affects the graph. Anyway, there's a b value right here, and that's going to affect the period, and there is an h value that is the phase shift. So we're going to need the period. The period is always the regular period divided by the b value. Now for cotangent, similar to tangent, the regular period is pi. So I'm going to start off with pi, and then I'm going to divide by this b value, which is 2. Alright, so that immediately gives me a period of pi over 2. We will deal with the x-intercepts later and the vertical asymptotes later. The phase shift is right here, though. It's the opposite of what it looks like, so it will be negative pi over 4, which puts it to the left. Okay, so when we graph cotangent or tangent, we start right in the middle. Now remember that cotangent is the reciprocal of tangent. I feel like I should write that down somewhere. Cotangent is 1 over the tangent. That's important because if you look at what the tangent function looks like, everywhere tangent is 0, that's going to make a vertical asymptote. Okay, so if tangent is 0, that's going to be undefined, so that's going to give you an asymptote. So looking at the normal look of the tangent function, just look at the yellow for a minute, the right hand side, because that's one period of the tangent function. It starts right at 0. So on the cotangent function, that should be an asymptote. And it ends right at 0. So that should also be an asymptote. So cotangent should start at an asymptote and end at an asymptote. Okay? And we'll do that right at the middle. Okay? So because of the phase shift, which is left pi over 4, instead of putting 0 in the middle like we normally would, we will put the phase shift in the middle. So I'm going to call this negative pi over 4, because that is the phase shift. Now if I were graphing the tangent function, I would go like this. I'd say, oh, tangent begins right here in the middle, and I would go over 1, 2, 3, 4, and I'd go, oh goodness, tangent ends right there. But we're graphing cotangent, so the deal is, if tangent is 0 right here on the x-axis, there should be an asymptote here instead of an intercept. So I'm going to replace these 2 points that I normally start with asymptotes. So I should have an asymptote for cotangent. I should have an asymptote right here in the middle. Okay, and if I count over 4 spaces, 1, 2, 3, 4, this should be an asymptote. So everywhere that the tangent function had an intercept, the cotangent function has an asymptote. Okay? Now, on the tangent function, right in the middle, there used to be an asymptote. So guess what? For the cotangent function right in the middle, that's where you're going to have an intercept. So everything is reversed. Alright? Everywhere that tangent has an intercept, cotangent has an asymptote. Everywhere that the tangent function has an asymptote, the cotangent function has an intercept. Just reverse everything. Okay, so this is basically how things are going to shape up for the cotangent function. This would be one period. Whenever we graph tangent or cotangent, we always do 2 periods, but we'll do that in a moment. What else? We need to label these values, though. We need to label them all. So how am I going to do that? Well, the period is pi over 2. So what I like to do, make sure I have the right colors, since each one of these marks represents 1/4 of a period, I like to figure out what is 1/4 of a period. Alright, what is 1/4 of a period? This is what I do anytime there's a phase shift. Alright, so 1/4 of a period. Again, if the period is pi over 2, then 1/4 of the period will be 1/4 of pi over 2, which is pi over 8. That means each one of these little marks is increasing by pi over 8. So that's why I'm going to add pi over 8 over and over again. So I want to take negative pi over 4 and I want to add pi over 8. Alright, but to do that, I really need like denominators. So what I would like to do is multiply these by 2. So wouldn't that give me negative 2 pi over 8? Alright, so now I can easily add 1 pi over 8. And that would just make, well, negative 2 plus 1 is negative 1. So this would make negative 1 pi over 8. Okay? And I'm just going to keep adding 1 pi over 8. If I added pi over 8 again, wouldn't that be 0? Alright, negative pi over 8 plus pi over 8, that would be 0. If I added pi over 8 again, 0 plus pi over 8 is just pi over 8. Alright, and if I add pi over 8 again, that would be 2 pi over 8. Okay, so most of these won't reduce, but, well, one of them can. So I often write my numbers down here when I'm adding so that I can easily reduce and the numbers aren't in my way. So most of these numbers I'm just going to write them down. So for example, negative pi over 8, that doesn't reduce. I'm just going to put negative pi over 8. Of course, 0 doesn't reduce. Pi over 8 does not reduce. 2 pi over 8 is the same thing as pi over 4. So that one did reduce. So pi over 4. Okay. We are going to need 2 periods. We always do 2 periods when we have the tangent or cotangent. So I'm going to actually keep going to the left with my counting and find more values. Alright, let me just erase this because it's a little bit in my way. Okay, so I was adding pi over 8 as I went to the right. So as I go to the left, I'm going to subtract pi over 8. And you know what? As I do this, remember, if I go over 4 spaces, that's going to be another period. So I might as well mark it off. 1, 2, 3, 4. Alright, so this should be another vertical asymptote over here. Alright, I will have to wind up redoing this later, but for now I'm just going to draw it. Okay, and while we're at it, we know that for the cotangent, right in the middle between the two asymptotes, there will be an intercept. Alright, now let's get back to labeling the x-axis. So instead of adding, now I'm subtracting 1 pi over 8. So if I start at negative 2 and I go down by 1, won't that be negative 3 pi over 8? And then negative 4 pi over 8. And negative 5 pi over 8. And negative 6 pi over 8. Now, some of these can reduce, can't they? Not negative 3 pi over 8, though, so I'm just going to put negative 3 pi over 8. Negative 4 pi over 8 reduces to negative pi over 2. Negative 5 pi over 8 can't reduce. But negative 6 pi over 8 reduces to negative 3 pi over 4. Alright, so these blue values are what we need. So I'm going to go ahead and erase all of these extra things. Alright, I don't need them anymore. And this work that I did up here, I'm going to erase all that. Okay, just in case it might be in my way. Okay, so let me just touch up my asymptotes here. Alright. I think we are good to go. Now, the A value is 2. So that's about to come into play. Let's go ahead and draw the y-axis in so I can mark off my A value. Now the y-axis is always at 0, so the y-axis is going to be right here. In fact, I think I'll just erase the 0, and because the y-axis will make it clear that this is in fact 0. Alright, great. There's my y-axis. Now I need to mark the value of the A value, which was 2. Okay, see it? There it is. So I'm going to mark this 2 above and below. So there's 2. I'll mark it here, and I will mark negative 2 down here. Alright, that's going to come into play when I do the graph. Now this is going to work very similar to the way the tangent function worked. The tangent function was always increasing, but it was just starting from any x-intercept from the midline. It was going to approach the asymptote, but it was always increasing. So the cotangent function is going to be very similar, except instead of increasing, cotangent is always going to be decreasing. Alright, so I'm just going to, if I start from this midline, cotangent is going to be decreasing. And it's going to be decreasing, and of course it has to approach the asymptote, so it's going to be going like this. But I'm going to be very careful. When I'm halfway there, it should be at this negative a value. Alright, it's decreasing, that's how I know it's the negative a value. So it should be going something like this. Whoa, I'm missing it. Alright, something like this. Okay, and meanwhile, if I take that same intercept and approach the other asymptote, it should be, well, from left to right, again, notice that it is falling. Alright, this is always falling. So it's falling from way up here down towards the asymptote. But halfway, it should be right here at the a value. So I'm going to try to hit that guy. So it is falling. Alright, so it should look something like that. So that's the left period. Now I'm going to get this intercept as well, but it's got to be falling into it. And again, halfway, it should be at the a value. So I'm going to try to hit that as well. So I'm falling, falling, falling. Alright, so that should look like that. And I'm going to continue falling, falling, falling. Cotangent's always falling. But at the halfway mark, it should be at negative a value. So it should be right there. So I'm going to try to hit that. Alright, so there you go. That's 2 periods of the cotangent function. Okay, let's talk about X-intercepts. Alright, notice that the this is 2 periods, okay? So the X-intercepts only happen once per period. So one of them is at 0. So I'm just going to use that one as kind of my starting number. Alright, so they only happen once per period. So I can say the X-intercepts will be at 0 and then plus multiples of the period. So that would be plus n pi over 2 because that's the period. But I don't need the 0, so I could just say n pi over 2, where n is an integer. Okay, vertical asymptotes. Vertical asymptotes also only happen once every period. Okay, you have to go an entire period before it occurs again. So I've got one positive one over here. For some reason, I'm just biased. I always, on my graph, if there's a positive 1, I take the first positive one. So that's pi over 4. So I'm going to start with the equation of any vertical asymptote starts out x equals, and then I'll say pi over 4. And then again, this is something that only happens once every period, so I could just add multiples of a period. So again, plus n pi over 2. Alright, and n is still an integer. So that's it for number 3. Alright, this video is already getting long. So I'm going to save number 4 for the next video.